Test review. Test will be Monday. I'll allow an hour and a half for it, although I think if you're totally prepared for this test, it will take you probably around 20 to 30 minutes. The test will only be over chapter 11 and 12 out of the Bernalini text. Okay, so I'm not going to ask you questions on the 31, 32 chapter handouts I gave you, or piping ISOs, things like that. So just 11 and 12. Yes, out of your drafting text of Bernalini. It's going to have several areas. It will have a picking area where I'm going to ask if you know the drawing names for the classifications of drawings. You're going to have a true-false section. And yes, the true-false will be like our standard true-false. If the question's true, mark it true and move to the next one. If the question is false, mark it false and correct the statement to read true. Okay, so half credit for each of those on a false one. There's going to be another section which is performance-based. You will have to draw a figure based on information given to you. I'm not going to ask that you bring your boards in for this. So it'll be kind of a sketch, but please use your triangles and get as good as you can. It will be an isometric sketch. You will start from 2 multi-views and produce the isometric for it. The last part will be there will be some drawings shown on your screen, on your piece of paper, and you will identify what types of drawings they are. I will include the setup on the drawings or something to help you, aid you in figuring out what's going on. Because if you remember, like on a 1-point perspective, we know the front side's true size and shape, the rest of it is not. A 2-point perspective, generally you have one line that's true size and shape, the rest of it's not. 3-point perspective, you have 1 point that is actually located where it's really at, the rest of it is not. An oblique, very similar to a 1-point, right? Isometric, diametric, trimetrics. And that will be the end of the test. I think the thing that will take you the most time is probably putting the isometric together. Any questions for me so far? It will be closed book, closed notes, everything on that. The object you're going to do isometrically is fairly simple. I don't envision you needing visualization tools for it, like clay and things of that nature, but you may want to be prepared for it. In essence, that's the test. Should we do a quick review of the chapters and what's important and what not?
Yes.
Okay, let's go to 11 then. Let's start in 11 and let me just kind of hit the highlights of it. Chapter 11 had 2 drawing types in it. Axonometric drawing types and oblique drawing types. Axonometrics, there's 3 types, right? Are axonometrics orthographic or parallel projection, or are they pictorial projection?
Repeat that.
Are axonometrics, the method we draw them, are they pictorial projection or orthographic projection?
Aren't they orthographic?
Yeah, ortho.
You're saying they're orthographic? I would agree with you. They are orthographic. But what's the difference between the 2 projection theories?
Orthographic is like kind of where your line of sight is, and then isn't the other one like you can move around and have many points seen?
And what causes that, Amy?
Line of sight?
The observer.
The observer, what's the difference between the observer? Because that's, you're on the right track. That is the difference between the two projection theories, is the observer. But what about the observer causes these differences? Observer, drawer, your eyeball. That's where your line of sight comes from, right?
Yeah. It's at infinity.
Yes. On an orthographic, the observer is at infinity, therefore your lines of sight are always parallel to each other. On a pictorial projection, you define the location of the viewer or observer, therefore your lines of sight are not parallel. That's the difference between the two projection theories. Axonometrics are done with orthographic projection. You have three types, they're shown right here, figure 11.3. Trimetric, dimetric, isometric. Know the differences between the three? Keep in mind which one's the most eye-pleasing?
Eye.
The tri.
Eye.
Which one has the most distortion? ISO.
ISO.
Which one did we focus on? Let me give you a hint. You did 3 drawings of one of these types. You didn't do any drawings of the rest of them. Isometrics. Know everything there is to know about isometrics, folks. I'm going to hit them hard. Because out of all these drawing types that we went over, axonometric, oblique, and pictorial, the one you're going to use the most in industry, without a doubt, is isometric. Know what a true isometric is versus a full-scale isometric. Know the rotation angle that is used to produce an isometric. Because we don't rotate the eye, we rotate the object, right? Anybody remember those 2 rotations we do with an object?
16
Say that out loud, please.
45-degree rotation, tilt, 35 degrees, 16 minutes.
Yep. You rotate it 45 degrees, like they show here, and then you tilt it 35 degrees, 16 minutes. That produces that 120 degrees between your axes. Keep in mind that 120 degrees sits right up in here on your main axes. When we draw them, we basically start on a horizontal line and go at 30 degrees for our 2 axes. The vertical axis is straight up and down. Are there any questions about isometrics? Now, I did mention that you're going to draw one of these. In essence, if we go to the, there's actually a pretty good picture for this on page 587 and 588. Okay, so what I'm going to have on the test is very similar to this, where I am going to give you a multi-view like this. I'll tell you right now, it's a 2-view drawing. And then you would then have to produce this view off of it. Yes, there will be a circle on it. Okay. Can you use an ellipse template to draw isometric ellipses? Don't use an ellipse template.
Yes.
They have 30-degree ellipse templates. They're not the same as an isometric ellipse. Remember, it's 35 degrees, 16 minutes, it's rotated. Okay, so those are different. You have to specifically use an isometric template, not an ellipse template for doing circles. I would like you to sketch it on this. Remember how to sketch circles on isometrically? Basically, you're going to define, if I was doing it on here, I would define where it's at, know which plane it's at, and you can just kind of divide that thing up and draw the quarters. Remember that process?
Yep.
Works very well, very easy to do, because you can basically measure on those, because it's full scale. The drawing I will ask you to do is a full scale isometric. It's not gonna be a true isometric, we don't have a scale for that, right? Review this, make sure you can do it. If you wanted to practice at something, they give you a bunch of these at the end of the chapter. I'm just gonna go show you. See, like, remember these guys, you actually did one of these drawings, the very first one?
Yeah.
Right here you have some multi-views, and then you produced a isometric off of it.
Can I do the calculator?
Are there any questions on axonometric? Next part was obliques. These started, gotta get there. In essence, on page 611, and move forward. Are obliques pictorial projection, or are they parallel projection?
Pictorial.
Yeah.
Go for the other one, Amy.
It's a form of pictorial drawings in which the most descriptive or natural view is treated as a front view. Oh, and it's placed on a parallel.
Yeah, it's parallel projection. So in essence, on obliques, again, you have three types. They are shown right here in figure 1159. Know the three types. You have the cavalier. Front side's true size and shape, your receding axis is full scale. You have your cabinet, front side's true size and shape, receding axis is half scale. You have your general, which is a combo of the two. Front side's true size and shape, receding axis is typically 3/4 scale. But it can be anywhere between half and full. That's to reduce distortion, right? You can recede that axis wherever you want to. In essence, these have a lot of distortion to them. Therefore, we had a couple of rules. These are shown on page 615 that we used to aid us in drawing them. First rule they went over, put difficult geometry in the front view. Difficult geometry, cylinders. Why? Because then they're circles, right? Front side's true size and shape. Easier to draw a circle than an ellipse. Second view, put the long axis parallel to the front view to remove that distortion as it goes back. It's a pretty good example. This one doesn't really look that distorted. This one does. This one is the first one I would choose. Keep in mind, if you can't get any of these to help your drawing out, then you start choosing different drawing types. Whether you're doing a cavalier, cabinet, or general. We didn't do any of these drawings, but I think you do need to recognize them and know what is viable on them and what is not. In essence, front side's all true size and shape, therefore you can scale off of it. The rest of it will not be. Any question on obliques? All right, then I think that's all for 11. Are there any questions on 11 that I did not cover that you wish to discuss? Okay, I'm going to start on page 637 of chapter 12 then. We then went to perspective drawings. There are again 3 types here. You should know the 3 types. 1 point, 2 point, and 3 point. I've kind of made a point of asking what type of projection theory is used with these drawings. And it's all leading up to this. Keep in mind, a 1 point is considered orthographic projection. That's this one. Now, do we define the location of the observer in a 1 point? The location of the observer, station point, do you define it? Yes, you do. So therefore, technically, it is pictorial projection, but a 1 point, we slide the object to the picture plane, that front view. And that draws most of the object. So therefore, a 1 point perspective is really orthographic projection. The 2 point and 3 point are pictorial projections. I would like you to know these three, what's viable with them. On this one, your front side, again, is usable in the building world. The receding axis is not. On a 2 point, you have no idea, unless you drew it, what's true size and shape on it. 3 point, again, you don't know what's right on this unless you drew it. Most eye-pleasing, most distortion, zone 2. I think you're finding on the 2 points you're doing, these look pretty darn good. For an untrained eye, you really can't tell the difference between a 2 point and a picture. So as far as this one goes, you should know the 3 drawing types, how they're put together. You might want to review page 639, which is the 1 point, and page 642, which is the 2 point, and how these are set up. We did have a few items that we went over terminology-wise. In essence, we used the first couple pages, 632, 633 for that. So does anybody have a question on what the station point is? Does anybody have a question on what a vanishing point is? Ground line? Horizon line? Picture plane? What about our cone of vision?
Yeah. Talk about that.
Yep, 30 degrees.
Mm-hmm.
Y'all good on all that stuff?
Mm-hmm.
Page 636. So the station point controls left and right? That's a variable. Height of the object's controlled by the relationship of the ground line and the horizon line. We had 4 different ways we ran them. Bird's eye view, human's eye view, ground line view, and worm view. I don't like worm's eye, they're kind of screamy. Maybe I call that vole, or let's call it ground squirrel.
Yeah, something like that.
Of course, voles are pretty ugly little creatures too. Know those. Any other variables on this? I think that's pretty much covering. You will not have to draw one of these. They take a little too long to do by hand, so it will not be on the test. But you've done plenty of them on your drawing, so I think they're covered. But you should know the specifics. The different items we use to set them up, the variables that we have, and how to recognize what's what. Any questions on those?
I don't worry about the measuring line. Okay.
True size line? Yeah, they call it a measuring line. I think, are you talking about 642, or they really only do it in one example,
Yeah.
which is on 642. So what they're talking about here is how do I move different heights, okay? And I remember when you're moving heights, you've got to get to the picture plane in this view. Okay? In essence, they're saying, hey, throw this one tree length line down, bring all of them over and do it. We did those slightly different because our picture plane crossed different heights of objects. And we had some objects that never crossed it, and so we had to extend them on the right orientation. No, the measuring line is not really, it's done a lot of different ways. One last thing on these, your top view, keep in mind you can do things with that top view in relationship to the picture plane too, can't you? If I put it all the way behind the picture plane, in essence, I'm making my drawing smaller, right? If I put it on the picture plane, it's true size and shape. If I put it in front, I'm making it larger. And if you're not following what I'm saying, I'll just kind of, so I can keep it here where I have that true size and shape, but I can also put it down here, right?
Yeah.
Now this drawing's gonna be larger here. I can also put it back here where nothing touches the picture, oh, it goes that way. Where nothing touches the picture plane, therefore it's gonna be smaller down here. All right, I think that's about everything you're gonna see. Is there anything on there you would like me to expand on?
Which time the test will start?
What?
The test, which time it will begin?
Does it start? 8:30 on Monday. Which means you probably ought to devote a little bit of time this weekend for reviewing this.
Just kidding.
Okay. Any other questions? I wanted to go to the drawing, your house drawing. Do you wish to use some pictures or blocks on this drawing? I'm just going to go over a couple things on it. I got to wait for my machine to boot up. You know, let's take a 5-minute break and let me get this teacher station set up. So if you need